Episode: Service and Analytics Deep Dive Review. Service and Telemetry and Analytics Plan Review Checklist. I have often recommended what I call the perpetual looping 5 stages of services and analytics engagement and course correction. That's a mouthful. The perpetual looping 5 stages of services and analytics, engagement, and course correction. Let's talk about them. The 5 stages are: 1. Data collection with dimensional context. 2. Raw data storage, including individual, personally identifiable information, PII, as well as aggregate data, its warehousing and replication. 3. Data map reduction. That includes rules reduction, derived dimensions, database joining, and reduced data. 4. Visualization. That includes dashboards, interactive data, database analyst interpretation. And 5. Act on insight. That includes tuning, content changes and updates, A/B testing decisions, targeted offers, revise or new, otherwise release timing, and content pricing. And then you loop back to number 1, which is why it is a perpetual loop of course correcting product development. So let's repeat those 5. Data collection, raw data storage, data map reduction, visualization, act on insight, loop back to number 1, data collection. So, let's talk about analytics engineering review and its deep dive checklists. So, have you done an analytics review? What do you want to know from your consumers? Is what you're collecting legal and privacy compliant? Is there cross-title, cross-device analytics? Are the telemetry and analytics plan scalable? Is 100% of the data collection drawn, or is it simply sampled from its consumers and or territories or regions? Is the bandwidth throttleable, as in can you change its analytics and how much cost it is to a consumer in the event their network is insufficient to manage it and the software experience? Is there a kill switch support to either completely end the software's operability or end its telemetry and collection? Is there a kill switch to stop or change a feature? Consumer managed telemetry. Consumers should be able to opt out of location-aware telemetry and further opt out of telemetry altogether. Telemetry should be able to be disabled for people who have to pay for their bandwidth connections. What about telemetry data collection and its schema? You should collect 100% of the baseline genre, cross-title, and game-specific or product-specific contextual telemetry for all devices, consoles, mobiles, tablets, PCs, whatever. Telemetry data, does it have a formal schema? And is it versioned to support revised schemas ongoing without data repository resets? Are all telemetry timestamped and associated with a user? And is it securely transmitted to a collector service? Is telemetry data included with feature mode buoys as well as bespoke event-triggered collection? Does telemetry data capture the events and the interval samples or other things when it does so? Common statistics, standard platform, user hardware information, etc. Are they all collected? Bespoke telemetry data is formally defined with actionable purposes, not just collecting in hopes of emergent discoverable value. So what is or is there bespoke telemetry that is being collected? Can the telemetry collected be compressed by the client? In other words, do min-max modifications against samples so you don't have to just collect everything and send everything. Perhaps as a sample over a few minutes and you accumulate a result in an average, a mean. The idea there is reduced bandwidth while still collecting the telemetry that matters for insight. And finally, in that space, does telemetry include dimensional contextual data? It's important to know what data was collected at the same time or related to other data in order to have better insight. Let's talk about telemetry data storage. Does the product store formatted raw data from clients in a scalable database in a common data center, ideally using some kind of forward hash user ID lookup for privacy and encoding? What is the database solution? Is it using SQL, SQL, Vertica, Azure, whatever, Azure SQL? What storage solutions does it use? And again, are they scalable and are they secure? Is there bifurcation from general database data and PII data? All telemetry is stored in a secure data repository in raw form for map production and is replicated in a quick access location. Is that correct? Flush or equivalent telemetry functions are used and are called at key locations in software to eliminate and reduce lost telemetry or fragmented memory. Is that done? Is telemetry stored offline for products that may operate while they're unconnected and transmit once they are eventually connected in the future? Let's talk about map reduction or reduced data. It's important to reduce raw data for analysis and join with other databases using common tools and servers. It is important for analysts, designers, user research, and development teams to all define questions to be answered to drive telemetry joining, and data reduction. It's important to store reduced data on fast databases for rapid interaction and visualization and real-time reporting. Again, I suggest things like Vertica, SQL, whatever. Let's talk about visualization of data. It's important to have analysts interactively analyze the data and create web reports for real-time tracking and viewing by others. It's valuable for dynamic editable game variables to be associated with telemetry via web pages so that everyone can see what can be changed and the impact they have on software. It's valuable to have web views for designers, separate views for engineers, separate ones for business analysts, BI, other ones for producers, and those for executives. You might want to use something like Tableau or Power View as software applications for visualization. And then finally, the act on insight. Well, it's valuable to tune content according to player interests and their behavior, including A/B testing to confirm that their ideas are valid. You can even test in small regions and areas or specific IP address ranges. It's valuable to surface telemetry in games to consumers in meaningful ways via hosted services. Consumers like to know how many monsters they killed, how much gold they picked up, how long they played, etc. It's valuable to communicate directly with users in-game. Having tools to do that would be valuable. It is important to determine ideal release timing, pricing, and marketing plans. All of these things and much more are the kinds of things you might act on the insight you've garnered from your analytics. Well, let's talk about an analyst review deep dive. What are the top responsibilities for an analyst to add value to the product or business? Analysts should define, drive, and join data from business intelligence, targeted segmentation, market and user research, and product telemetry and platform telemetry data to unify a relevant single database repository. They should provide analysis, recommendations, and distilled interpretation of market research and segmentation, product concept and quant and qual research, product and platform user research and telemetry insight, etc. They should track and report product usage, consumer behavior and trends, and comparable product performance. They should drive and guide product telemetry requirements, individual and in aggregate. They should engage studio analytic teams to harvest and share best practices and tools across the entire business. What are the top skills that are required by an analyst? It is the ability to directly use and manipulate complex databases from various sources, selectively joining data sets and schemas and interfaces, and further interface with other analysts, information technologists, IT, and management teams to secure the relevant access and information. They should understand the various research mediums, formats, analysis, distillation, and presentation to deliver executive reports, summaries, and interpretation walks, and deep data repository and sharing. They should have the expertise in deriving key information from complex databases and schemas and developing dashboards using products such as Tableau or Power View, and documents, presenting things in decks, documents, Excel, whatever works. They should have operational leadership and project management ability to guide and wrangle telemetry requirements, adapt to video game real-time analytics versus web click-through traditional digital analytics, document, drive, and influence adoption and integration for individual product and common aggregate telemetry. They should have the adaptability to politically engage across multiple organizations as a partner to inspire collaboration, sharing, and evangelize best practices and tools for analytics and its adoption. Well, if that wasn't enough for you, now this is a Service Engineering Review Deep Dive. So let's talk about formal software, tools, and organization structure for operations and consumer support. There should be documented roles and responsibilities, on-call resources, response and run books, and automated recovery and restart systems. There should be documented what success looks like, key success indicators and key performance indicators, WSLL, KSI, and KPIs, that measure multiple interval tool, site, and product success, uptime, transactions per second, lag, load and access times, etc. There should be formal documented surface, life cycle, and strategy plans. It should include roadmaps, customer satisfaction surveys, feedback and communication systems, and technologies. There should be live production site and release management plans. There should be a virtual machine, VM isolation, and replication ability to dynamically throttle service instances to accommodate load and control costs. There should be dedicated, separate machine and human resources that support live production sites and products. There should be log data collected that enable troubleshooting issues and their origins and replicating the environment or state to enable reproducing those issues so they might be fixed. There should be code and content modularity to support automated component and full system deployment, rollbacks, and interdependency versioning and verification. There should be release management processes and release managers formally assigned to oversee all release candidates for test, interoperability, and quality. There should be unit tests and service exercise test beds and harnesses in places to test services and updates in live production as well as in staging environments. There should be a kill switch available to terminate any given feature or service, as well as telemetry analytics. There should be staging site readiness prior to live deployment. Staging and live production sites and services may be location agnostic, but they may not be. So you may need to deploy remote servers or integrate in-software network problem simulation, simulating lost packets, lost bandwidth, complete disconnects, whatever. Production and staging site environments and URLs that are resolved according to separate domain name services, DNS, should not be used. Not until you're in staging and production. Before that, they should be assigned with static, IP, port, URLs, and paths, etc. However, once they are in staging and live, they need to be dynamically resolved by a DNS so that there are no longer hard-coded paths. Everything can be changed remotely. Client and service URLs should be configured from one master remapping URL. In other words, there should be one configuration file that tells the software where it should connect and how to connect, what it should do, etc. Let's talk about service health and availability now. Automated monitoring of holistic services, farms, clouds, geolocations, machines, VMs, individual service modules, components, all of that needs to be monitored. There should be automated monitoring of quality of service, or QoS, and operating status, and response systems, including call to action emails, systems that will text, call, email, otherwise contact real people to get involved to solve otherwise insolvable problems. There should be documented quality of service, key performance indicators, KPIs, operating status, expectations, trend tracking plans, and predictive analysis and reporting in place before it goes into staging. Quality of service includes holistic operating services from client and consumer perspectives, not just server uptime. Quality of service includes mean time to detection, MTTD, and mean time to recovery, MTTR, from any incident or fault or failure. Internal and external and multi-tier quality of service and monitored status dashboards, reports, and databases should always be operable and available. There should be service level objectives defined and service level agreements in place with supporting resources and infrastructure for clients and partners. There should be documented KPIs for quality of service. I say again. There should be service resilience. It must be fault tolerant. It must endure power outages, system and machine VM subservice total failures, data center complete failure. Disaster recoverability includes regular full site service and data backups and the ability to rapidly recover and redeploy, even change the data centers that are hosting the services. Well, all right, let's talk about data management. It's important that all private and identifiable information is securely transmitted, such as using a protocol like HTTPS, and protected, encrypted, hashed, and stored in a secured location through data lifecycle, as in creation, transmission, storage, and backup retention across all services and modules. It's important for all client and user data to be validated for appropriate format, content size under and overruns, etc. This will help prevent exploits and hacks against the system. It is valuable to have telemetry and user data, raw data, stored in a safe access area and replicated for quick use and for database joining. It is valuable to have load balancing in place to support large-scale concurrent connections, distributed load demand across multiple machines and even across data centers. It's valuable to have data read versus write coherency integrated in peer service and server and client access designs, including using at least some kind of semaphore modeling where critical. It is important for privacy management and identity obfuscation and hash enabling direct targeted communications to do so without direct identification and association. It is valuable for personal identifiable information, PII, to be stored in secure, separate locations from bulk data with obfuscated indexing as well as encryption. Any association back to bulk data must only be associated by an index or an ID, not the actual consumer identification ID. It is valuable to use formalized audits for PII isolation and to formally audit against hack and ingestion exploits and the otherwise service defensibility against hackers. It is important to have kill switches available to terminate internal and external system accesses to data and personally identifiable information. It is valuable to have the ability to block specific users, accounts, IP ranges or ports, products from accessing any level of data, whether it be individual, product, or group. You need to be able to ban and block threats to the system and to your service. Let's talk about service business model and return on investment, ROI pragmatism. It's important to model product purchase versus product subscription plans and look at the expense revenue model for its solvency in near and long term. It is important to understand the feature or system designs and the resource requirements and the decisions that are based on data, not on guts or intuition. It is critical to use objective information to make service-based decisions. It is valuable for capital expenses and operational expenses to be appropriate for the service. In other words, what does the maintenance, CDN, cloud storage, bandwidth and processing and resourcing cost? Does the revenue business model justify the hosting? It's valuable to understand the end-to-end cost that is fully understood. All capital expenditures and all operating expenditures, CapEx and OpEx. It is valuable to understand storage, bandwidth, and processing requirements, concurrent user connections, transactions per second, TPS, as well as how you'll measure and forecast all of the above. It is valuable for load testing and account management tools to be made and used to validate service stability overall and across all service locations and warehouses. Let's talk about accessibility and usability now. Consumer and relevant product user interfaces accommodate users with disabilities or handicaps, including adherence to territory laws. Has this been done? It's valuable for the service to have age requirements, gender requirements potentially, location access management and other control restrictions in order to be compliant with target territories and laws. We individually may disagree with age and gender and location restrictions, but if you intend to release your product across the world, those systems must be in place. For example, there are countries where a 14-year-old boy may do something, but a 14-year-old girl may not. It may be wrong, but it is unfortunately reality. It is valuable for accessibility and usability service aspects to fully test to ensure there are no exploits or data issues, as these are often undermanaged areas. It is valuable for internationalization and localization to exist for relevant service modules and components. Everything should be localized. Now let's talk about monetization. Monetization and charging solutions are appropriate per territory and backed by establishing banking institutions. Has that all been cleared with all the related parties? Finance, legal, outsourcing, whoever. It's valuable to have credit card and bank information properly managed, secured, and stored in compliance with individual territory and regional laws. It's important for content offerings to have appropriate territory and global distribution, sale, and licensing rights. It is important for marketplace offerings to be tied to territories and regions versus being a global offering. A/B testing should be available for all marketplace offerings. It's valuable for user rating systems to exist for any content that is offered and offer automated revocation systems in place, as well as moderators to approve or reject content should that be required in a given region. Let's talk about service engineering agility. There should be time, process, tools, and workflows to make, test, and deploy any change to the service, its technology, features, or capabilities. There should always be service module interfaces and library abstract program interfaces, APIs, properly to isolate internal implementation from client engineers to allow internal code modifications and wholesale re-architecture and replacements without impact. That's complex. It's valuable to have abstractions that exist for all APIs and module interfaces to allow complete engine replacement so products can develop for years to come with the same software dependencies. It is valuable to have planned release cadence, release versioning, major, minor patch, and release communication, FAQs, notes, as in frequently asked questions, online sources in software, whatever, push versus pull updates, and so on. It is valuable for the product quality of service and uptime tracking and visibility for internal and external sites to be reported in dashboards and tools and always be monitored. It is important for service-oriented architecture, SOAs, to support interoperable services and real-time modular updates. It is valuable For partial versus whole binary update capabilities, you should be able to update a piece of software or at least a small component of assets instead of the entire package. It is important for consistency, availability, and partition, CAP, tolerance, integrated into the service and module architecture with formal module interfaces defined. It is important for version control and release revision tools and processes, plus labels and snapshots for code, data, and schemas. It is important for concurrent automated builds with automatic email communicated breaks and issues to standby teams. It is critical to have labeled builds, last known good builds, ship ready builds, and already shipped builds for all code and data always maintained. It is important for unit tests, automated extent and limit testing, and test harnesses, test beds, all to facilitate development and validation prior to deployment. It is valuable for debugging tools and environment state reproduction capabilities to be there for the team at all times. And finally, let's talk about engineering and tool debt. What is known? What has been deferred? What should be refactored or followed up on? What do we know corrections must be done? What fixes to existing tools, pipelines, technologies, or even processes need to be made? It's all very complicated. Once more, I hope that there has been some insight from this episode, some nugget that will help you in your professional career.